Hello everyone and welcome back to Casa Cloud. Let's consider a scenario that we need to deploy a particular microservice in Kubernetes. Then we'll be creating few of deployment definition files like deploy.yaml, service.yaml, persistent volume claim, and few other files if required. But now, if I want to repeat this particular process of creating multiple files for a particular microservice for 20 other microservices, it will be hard for me to manage all these YAML files. And it doesn't stop there. If I want to upgrade a particular version of a particular microservice or do a small change or maybe roll back a particular microservice from its current version, this will be tedious task for a Devops engineer to manage. To resolve this issue, we have Helm charts. Helm chart is nothing but a package manager. So to get the contents of today's video, you can go and download this particular Helm chart repository from Casa Cloud. You just need to go click on the Helm chart and you can click on code and you can just go HTTP and copy, and you can go to your favorite IDE and just do git clone and paste this particular URL and you will be able to pull the entire repository in your local. What is Helm chart? Helm chart is a package manager for Kubernetes, the best way to share a software built for Kubernetes, and it's kind of a homebrew for your Mac. Like you want to install any of the software in your Mac, you'll be using homebrew, or if it is a Linux, then you'll be using apt, right, to install any of the software. Helm chart is similar only in the case of Kubernetes. If you want to install a particular software in Kubernetes and if you want to directly install it from a source, then you can utilize Helm. The charts are easy to create. You can create version numbers of the chart. You can share and publish. How will you share and publish? There is a artifact hub. This is the hub for all the charts offered by Helm. So if you have an application and you create your own chart, you can also deploy your chart here and you can share it to other developers. So for example, if I want to just install Elasticsearch, then I can just search for Elasticsearch and I'll get all the Elasticsearch charts offered in this particular repository. So I'll go for the organization Elasticsearch and here I'll be seeing the entire chart here and all the details about the chart, how to install, what are the details, what are the requirements, how much RAM is expected, what is the process of installing, the entire command and everything. And if you want to just pull the entire repository, then you can just pull a GitHub and you can do Helm install from your particular local machine as well. Okay, so this is Artifact Hub. You'll get n number of repositories here. So let's go back to our repository. Yeah, so Helm is a graduated project from CNCF and now maintained by Helm community. So Helm package is referred as a chart. So up till now, we have already created a Node.js microservice and we have pushed it inside the Azure Container Registry. If you go to the channel and you find this particular playlist, start here, Devops full course for 2025. And here I'm at the last of the playlist. Here we have created a Node.js microservice from scratch and we have created a Azure Container Registry. We connected that Azure Container Registry to Kubernetes and pushed that particular Docker image of that particular node microservice inside the Azure Container Registry. If we get inside portal.azure.com and if we go to resource group 4, here I have the Casa ACR01 container registry, and if we go to this repository, Node.js template, this is the particular name of the image and the version is version 0.0.6. Right now it is present in the container registry. So step 1 is already completed. We have already created the image and pushed it to the container registry, and today we are doing the step 2, that is create Helm chart to push the image from container registry to AKS. Once we install this, step 3 will automatically happen, that is pull the image provided in the container registry to the AKS. So let's go through some history of Helm. Helm started like in October 2015, and in 2016 itself it had its version V2 released, and in 2019 it had its Helm version V3, which is currently active. So this is the current and the latest version of Helm. Helm uses semantic versioning. This is versioning of any of the chart that we are creating. This is not specific to Helm, but semantic versioning we can apply to anywhere. So if you have your own application and you want to provide a version number to it, then you can use a semantic versioning. So what it states, if you have a breaking API in your updated version of the application, then you need to upgrade to your major version. And if you have new features added to your existing application which is not breaking your older version, then you can increase your minor version. And if you just have patches added to fix some kind of bugs, then you can just increase the patch. So this is semantic versioning that Helm also uses. Supported platforms. Helm supports all the three platforms. Helm.sh is the website. This is the website of Helm, and the artifact hub that we have seen, from where we can download the public charts for the public softwares like Elasticsearch, Kibana, MongoDB, and any other software that you wish, which is the public domain. So how to search a chart from command prompt? We also have, once we install Helm, then we can directly search a chart from the hub, that is artifact hub, and the name of the chart. You should be able to see any chart possible. Here, if we do Helm chart search and maybe Elastic, maybe see what are the offerings from the Elasticsearch. So we have many offerings given, so we can search and select the best one that we want, and that's how we can select the charts from the command prompt. Okay, how to install in Mac? If you are using Homebrew, then you can just install Helm. We have the offering for Windows as well, and if you want to directly install it from the source, then you can directly install the sources. The current version we can see and validate just by using Helm version. The current version is version 3.17.3 during the recording of the video. Okay, so Helm chart from 1000. So this particular chart, or this format, if you see chart.yml, charts, templates, notes, everything, this is created by a simple command, Helm create chart name. Once we provide this command, then it will create this particular package for us with some default files inside it. So let's understand. The chart.yml is the high level package information where we get the metadata about the chart, like the name of the chart, version of the chart, if there are any dependencies for that particular chart. These details we'll see in chart.yml about the chart. Then the default configurations will be present in values.yml. We were talking about the Kubernetes deployment file, services file, then versus storage, versus volume claim, and all the other YAML files. So this values.yml keep all the configuration files related to your Kubernetes deployment file, ingress file, services and service account, and any other file that you have. All the static configurations we'll see inside this value.yml. Okay. Then we have the manifest folder, that is templates. Here we have all the service, deployment, and other files that we wish to create inside the Kubernetes deployment. Then we also have the test folder. In the test folder will help you, once the chart is deployed, to validate whether the required service pod deployment replica sets are created or not. We can create particular test for those. For that we can have this test. Deep dive in chart.yml. So mainly it is metadata and also the dependent. Okay, metadata, we have the API version. Here we have the v2, name of the application, description, type is application, and then the version of the chart and the application. And then we also have the dependencies. Let's suppose I have a application which is based on MariaDB or MongoDB, then I'll give this dependency as chart dependency. So first this chart will be installed. That means this particular DB will be installed before my application. Next is values.yaml. In values.yaml, we can, as I said, we keep the default settings of the chart, like replica count, image, what is the name of the image, what is the tag of the image, then the service details, what is the type of service, what is the port of the service, and if there is any secret involved, then what is the secret, and many other things. Depends on what kind of Kubernetes deployment definition file that you are creating. Whichever meaningful configuration that you can keep inside this file, you can keep it. So it is open. Overriding the chart values from left to right. So we can provide -f during the installation, helm install my release, and then chart my app, and I am sending the file that is custom.yaml. So there is another option to send, not only a particular file which includes all the variables. I can set a particular value as well using the -set. But in the advanced use case, we can add multiple files, we can set multiple variables, and it goes from left to right. Whichever is the rightmost will take the highest precedence, and whichever is the leftmost will take the lowest precedence if you have the same variable in the leftmost file and in the rightmost file, or in the set command. Okay, so the template directory, anything here is treated as the YAML template. It has a Golang template language. So this is based on a template engine where it is controlled on the Golang language. It takes the values from the values.yaml. Understand? All the values from values.yaml are read in this templates, like this particular includes value.fullname, my name, values.replica count, selector label, app labels, anything that you wish to read from the values.yaml file. Next, we have the template helper file, which is optional. This is for selection of the YAML that you may repeat in all the, like if you want to add kind of a selector label or tags to all the deployment definition files, then you can use this template helper.tpl file. Then we have a test file. A test file is very simple. That let's suppose I have installed a particular microservice which is exposed on 9000 port. Then I may utilize this test, a simple test that will tell use a busybox image, and command is wget, and in the argument I'll say just ping this particular port. Okay, so the name of the service and colon the port number of the service. So if it responds, that means my test is passed, and if it does not respond back with the valid status code, then the test will. So as your application grows, you can create your test cases. So now we have the notes.txt. This is very interesting. Once the application is completely installed, it will print this. Okay, then installing a Helm chart. What are the ways you can have the chart installed possibly? There are only two ways. One is from the hub, where we have the ready-made templates or ready-made charts. So you can use the hub, like install Helm, install my release, the repo and the name, or you have it in your local folder you have created using the Helm create command. Eventually both will deploy the application inside Kubernetes cluster itself. Checking the release status of the chart. Once the chart is released or it is installed, we can always keep on checking the status. If the status is deployed, that means the chart is deployed already. Version will keep on increasing. We can see all the installed charts using the Helm list command, and then we can upgrade a specific Helm release using the Helm upgrade. We need to give the release name and then the chart name, and we need to set a particular value that we will set, and it will be upgraded. Once we upgrade, the release revision will be updated to 2. Okay, so this will help us to keep a track in what release number we are if we install through Helm. So if we can upgrade, then we can roll back as Helm rollback release 1. That means I want previous image, because in this Helm upgrade I have set a particular stack from the existing one. Now I want to go to the previous tag, then I can go Helm rollback release name and then the revision number. This way we'll go to again release 1, but interestingly, if you see the Helm status again, then it will show you the release number is 3, because now it will always be incremental. Though you have gone to release number 1, it is a bit conflicting, but if you plainly see, the release cannot ever go back. It will always count +1, but you need to make sure in which particular release what you have done, that you can track. Okay, then we have deleting a release, Helm delete and delete my release. The entire release will be deleted, and all the files that we have added, which was the part inside the template folder, all those workloads will be deleted from. Okay, so it is very simple and handy because it is a package, so it works with package. When we install as a package, all the workload files that we have will be installed at a time and just deletes by its own with just one. Okay, let's go and we can create a chart. Helm create Node.js template. Why Node.js template? We already have this particular Node.js microservice, right? Hence we are just continuing to create a Helm chart for this microservice itself. We already have the Node.js template image present, ACR. So we'll try to create this Helm chart with Node.js template. IDE do Helm create Node.js template. Instead of this, 01 dash and press enter. Then it will create this particular chart as you see here, has the chart template Helm ignore file, chart.yml and the values. Let's go through it step by step. In the chart.yml, as expected, we have the chart metadata, application version, name, description, and then the icon. If you give this particular icon and if you push your chart to any of the public repository, then this icon will be used. Okay, then my type is application, version, the chart version, and this is the application. It is just a sample for now, but you can meaningfully keep for your. Okay, then we have the templates file. The template file is including the test file. The test file is, as we have just seen, simple test file with wget. You can add as many tests as you want. We have the helper.tpl file. It is auto created. I haven't created this. When I gave the Helm create command, it has created this one. This is the deployment file that we have. This is the format through which we read the values either from the environment variable or from the values.yaml file. So this is the release name and then the values.name. Release name is when we create a release, we need to give a name to that particular release, and values.name is inside the values.yaml. If we open it to the side, you can see the values.name. So that is yes template. Okay, so similarly I'm giving the space global.namespace, global.space here. So this will all be rendered. Then I have the replica. I can even shift the replica count here using the values replica count, and it should take it. Okay, and then I have the match label name, again values.name, container name is but again dot name, which is just template. Then I have the image. The image is but this particular image, set image repository. So my image repository, if we go back to this, my ACR has the server URL Casa acr01.azure.cr.io. Okay, so the exact same DNS slash node.js template, which is nothing but my repository, which is this is JS template. Okay, and inside that, if you go dot values colon, I'm giving the tag. What is the tag? Version 1.0.6, which is the installed version. This version exists inside my ACR, that is Azure Container Registry. Perfect. And then I'm giving the container port 80 and few of the environment variables that are required for my Microservice. Okay, perfect. So let's go, and first I want you to lint your application, that is Helm lint. So what it will do, if there is any syntax issue with your Helm chart, you need to do linting Helm lint, and you need to give the chart. Okay, so it has linted one particular chart and 0 failed, so our chart is good. Now how do we ensure that the rendered file, that is the rendered deployment definition files, are taking the right values or not before I install this inside the Kubernetes? So for the Helm install, we have an option called as dry run --debug. If you see here, we have dry run --debug. What is this? Helm install. I'm giving the release name. My release name is Node.js, right? And then I'm giving the chart name, that is, and I'm calling dry run --debug. I execute this command, it won't actually install the components inside the Kubernetes, but it will display me the values that I'll be using for this installation and the rendered YAML files that are templates. Okay, let's see this. So it is reading this particular chart. Okay, so these are the variables that it is trying to use. At this, these are the variables: container port, environment port. It is reading from the values.yaml file. It is quite simple right now because there is only one file, but let's understand that if we have multiple values file and there are duplicates inside that file, then which file or which value has taken the precedence, we can confirm using this. Okay, then we start with the test connection.yaml file. It has rendered this test connection where we have the pod, specs, container, and Node.js template :80. Okay, so this is how it has rendered this from test.yaml file. It has replaced full name, it has replaced the port from this, and that's how it has rendered. Next is service.yaml file. If I go inside the template, I should have the service.yaml file as well. This service.yaml file is only exposing the port, target port, protocol, and the name is this. What is the type? The type is cluster IP, and my port is port number 80. So it is creating a cluster IP type of service. So this is the rendered file, and the third one is the deployment. The deployment file is this particular thing, which is again replaced with all the values from this values.yaml. It looks good. If you are confident that this is what you want, then what you can do is you can go back to your previous command. Right now, let's check if we have Helm list. Do we have any chart installed? No, currently we do not have any chart installed. You can do now Helm install, the name of the release, and then 01, that is the chart name, and it will try to install this inside the Kubernetes. For this to complete, it uses the kubeconfig file, which is present inside your local host right now. For that, you need to make sure you are logged in. So you need to make sure you do EZ, and also you need to make sure that pull Kubernetes config as well. If you want to take the reference, then you can go back to Casa Cloud, Azure, inside the Azure RBAC, 01, you have the steps how to log in and pull the Kubernetes config. That is AZ login, AZ AKS get credentials, give the name of the AKS and the resource group and override existing, and then convert your kube file for the kube login. So these are the mandatory steps before you do the Helm. Okay, that is done. So once this is done, let me see, the chart is already installed. Let's do Helm list. Yes, my chart is installed in the default namespace, and the name of the release is Node.js template. Now let's see Helm status Node.js template. Now we can see the status, it is deployed. Okay, it's on revision number 1. So if I want to just go and really check the Kubernetes which is installed, let's go to resource group for AKS workloads, and we can see here Node.js template dash Node.js template which is installed in the default namespace. The pod is healthy and running, and if I can go and here as well, you can see kubectl get pods. You'll be able to see the pods. Kubectl get deploy, we should get the deployment. Kubectl get svc, we should be able to see the service that is created. Okay, so all the deployment files that we had are all installed. So here we have already seen that what is the format. You need to do the linting. You can do the dry run using the dry run minus debug, and then if all things are good, then you can install any of the chart, and then we can do the Helm list as well. It will list all the listed charts, and then if I want to just delete the current Helm chart, then Helm list Helm uninstall Node.js template, then it will try to uninstall the particular template. Okay, it is uninstalled. If I do kubectl get pods, I see that the pod is started to terminate. That means all the deployment that we have installed is now getting removed. Get svc, the service is also removed, and kubectl get deploy, the deployment is also removed. So this is what I wanted to showcase to you in this particular video, that is introduction to Helm chart. I'll see you in the next video. Till then, take care.